All right, here we go. We're venturing now, finally, into Chapter 3. Okay, Chapters 1 and 2 had a lot of sections and a lot of information. It took a long time to get through them. So now we're finally moving on. Yay, 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 yay. All right, so we're kind of doing a double whammy today because sections 1 and 2 of Chapter 3 include an awful lot of review. And so we're going to lump them together and go from there. So at the top of your notes, start by saying 3-1, ordered pairs. Okay, and again, pause the video at any point you need to catch up. Now, your learning target today for these ordered pairs is basically to do this. And here's where you might want to pause the video to get this written down. I can write solutions of equations in 2 variables as ordered pairs. Get that. Pause the video if you need to. Okay. So I guess the first thing we need to get through is a vocabulary term for what does it mean to have an ordered pair. Well, if you break apart what the words mean, the pair part means you have 2 numbers. And then the order has to do with that they represent a point or a certain location on the coordinate system. And the first number is usually considered the x term. The second number is the y term. And you always have to denote them with parentheses. It's almost like this is like a GPS location where it's giving you the exact coordinates of where you are. It's the exact same thing. Okay, so that's what an ordered pair is. So what you're going to do today is you're going to get an equation and it has 2 variables in it. Usually it's x and y. It might be other letters as well, but usually it's x and y. So here's one. Y equals 4x minus 1. And some of the questions you're going to get are, tell me whether each one of these actually is a solution to this system. Okay, so let's try this first one, knowing that in this case, the 2 is the x, the 4 is the y. Show me a little bit of work here. So start with 4 times 2 minus 1. Okay, that's plugging in a 2 for the x. Do you get 4 for your final answer? Well, this gives me 8, and 8 minus 1 is 7. So this one is no. Let's look at the next one, 3, 3. I have to take and plug this in for my x value, 4 times 3 minus 1. We have to say, does that equal 3? This is 12. 12 minus 1 is 11. Nope. That one doesn't work either. How about 1, 3? This is the x value. This is the y value. I take 4 times the x value minus 1. Does that equal 3? Well, 4 times 1 is 4, and 4 minus 1, yes, indeed, is 3. Yes, it is. Okay. Now, the big question is, can there be more than one solution? Could you come up with another one? Well, sure you could. You could pick a value for x, like let's pick say 2. If x were 2, I'm going to come over here. If x were 2, 4 times 2 minus 1, we said you should get 7 for your answer. So because 8 minus 1 is 7, that means if I plug in a 2 for my x value, I can get a 7 for my y value. Does that one work? Yes, it does. So is there more than one solution? Yes, there is. There can be. So your job is to, when you're given some ordered pairs, you go ahead and check them. All right, sometimes it's a lot easier to look at these by making a table of values, and that just makes it that much easier. So take a look at this one and get it jotted down. Alrighty, so we can make this big table here. And what we're after is I've got this equation. N equals 6m minus 5. We're going to plug in values for m of 1, 2, and 3. So make these 1, 2, 3, 4 columns here. We're going to start with the m, and I'm telling you what to plug in here, a 1, a 2, and a 3. Okay? Here I've got the equation, n equals 6m minus 5. So every single time, we're going to take this m value of 1 and plug it in right here. Okay, so n equals 6 times 1 minus 5. And use your order of operations to say, okay, this comes first. 6 times 1 is 6 minus 5. That gives you a 1 for n when I crank that out. So my ordered pair is 1, 1. Make sure you write it in parentheses. Next one, now evaluate for m is 2. So we say n equals 6 times 2 minus 5. So you say to yourself, all right, that's 12, and 12 minus 5 equals 7. All right, so my ordered pair, when I plug in a 2 for m, I get a 7 for n. And the last one at 3, n equals 6 times 3 minus 5. Well, 6 times 3 is 18, and 18 minus 5 is 13. So a 3 for n gives me a 13. Put parentheses around it. There's your ordered pair. Okay, all 3 of these are what we call solutions, or ordered pairs that work in this particular equation. Alrighty, so those are the kind of things that you're going to do in the first part of your assignment, which is going to be in the workbook. All right. However, we're going to zoom and look at one word problem here as well. Okay. Now you don't have to write this down, but we're going to translate this information. It says a plumbing company charges $50 for the service call. So that means just to come out to your house, it's $50. Plus, they're going to charge you $15 per hour for the work. They went on a 3-hour job. How much did the company earn? First thing it says is, can you come up with a 2-variable equation to relate the hours that are worked to the money that was earned or charged? Now, you can use X and Y if you want, if that makes you more comfortable. Okay, it's where this is going to be X, the hours, and Y is the money. If you want to use H for hours and M for money, you can do that too. Okay, I'm going to stick with X and Y. All right, so here's the deal. The hours. I know I charge $15 for every hour that we work. So I know I have to take 15 times X. But I also have this $50 that gets added on. The $50 gets added on no matter what. And this is going to equal the total amount of money. Okay, now we can put it at the beginning or the end. It doesn't matter. But this is the money. Okay, and the money is going to be $15 times the hours. Okay, so 15 times the hours plus that $50 startup. So if it helps you to kind of put the words there first and then drop the variable in, super. Now here it's saying, hey, could you please then figure out and show how much you'd earn if my hours, which is X, would be either 2, 4, 6, or 8 hours. So you'd say, okay, well, so here's my column for X. X is going to be 2, 4, 6, or 8. My equation looks like this. Y equals 15X plus 50. Okay, so that's your second column. Then your third column is going to be just what is the Y value. Remember, this is the money. If you need to put a little sign there to help you remember that that's the money. And then the last column is writing the ordered pair. Okay, so here we go. Plug in a 2. So Y equals 15 times 2 plus 50. Well, that's 30. 30 plus 50 is 80. So 2 hours, $80. Okay, plug in a 4 and do the same thing. Y equals 15 times 4 plus 50. That's 60 plus 50. That gives me, I believe, 110. By the way, check it on your calculator because heaven knows it's early in the morning and I doubt I've had enough coffee to make sure I'm computing correctly. $110. Next one is 6. 15 times 6 and then plus 50. 15 times 6 is 90, 90, 50, 140. So if it was a 6-hour job, $140 is what gets charged. And then last but not least, let me zoom this up here. if it's an 8-hour job, that's a lot of plumbing. 15 times 8 plus 50. All right, that gives me 120 plus 50 more is 170. 8 hours, $170. And psst, by the way, this is not a very realistic example because plumbers make way more than $15 an hour. Consider that as a job. It's a hard job, but they definitely charge more than that because it is a hard job. Okay, so that's the kind of stuff you're going to do in section 1. All right, draw a squiggle line on your notes, because now actually what we're going to do, let me fast forward a little bit here, is now cover the second section, which goes super fast. 3-2, graphing on a coordinate plane. All right, and again, pause so you get all the words down because I'm just going to keep on rolling along. All right, your learning target for this section is that I can graph points and lines on the coordinate plane. So today we're going to be actually getting on the grid and graphing and showing where these ordered pairs are and where they live and reside on the coordinate system. Okay, here we go. All right, I need you to draw, or if it's on your note sheet there, draw this. So it looks like two big old lines that intersect. And you've seen these before, so let's get the terminology down. Okay, first of all, we call this the coordinate plane or the coordinate system. Two number lines that intersect at 0 right here. Okay, and you can kind of put a big point there or a dot because we're going to talk about a lot of these things. Put an X right here on the horizontal. Put a Y right up there. You've heard this terminology before. Okay, the origin is basically where the two lines meet. It is this point, 0, 0, 0, 0. You have to put parentheses around it. That means it's that specific point. The x-axis is the horizontal one. Okay, it's the horizontal number line. It's also always the point that is named first in your ordered pair. So it's always the left-right direction. The y-axis is this guy. That's your vertical. And it always represents the second value in your ordered pair. Now, that makes 4 different sections here in your coordinate grid called quadrants. Okay, so these are the 4 sections of the coordinate system. And here's how we denote them. Rather than using Arabic numbers 1, 2, 3, 4 like this, we don't do that because we don't want to mix that up with perhaps one of the coordinates. So we use Roman numerals 1, 2, 3, 4. And we start up here. Okay. Here's the first one. 1. It kind of looks like capital I. And then we go in a counterclockwise direction. Okay. So we're going to travel this way with our numbers. And again, we're going to use, I'm going to get this out of the way now. We're going to use Roman numerals to denote what we're talking about. So second quadrant is going to end up right here. Roman numeral 2. This one is Roman numeral 3. And Roman numeral 4, some really old clocks actually do 4 I's, but it's standard notation in the Roman numeral system to write IV. And when the I comes before the V, which is 5, you take 1 away. That's why this represents a 4. All right, quadrants. The origin, the axis for X and the axis for Y. The ordered pairs are always written X, comma, Y. And you have to put them in parentheses. All right. So let's take a look at these. Okay. Here's your first point, -3, 5. This is the X value, the Y value. Go ahead and graph that point. I'm going to change colors so you see. This is black. -3 means go to the left, to the left, to the left, 3. And then go up 5. There's where your point is. You don't have to graph, or I should say label it on here. Just get the point on there. And in fact, pause the video and put the rest of these on here and then start it up again and match and see if you match mine. I'm going to continue on. 2, -4 is the point right here. That is in quadrant number 4. Okay. This first one, -3, 5. That one actually is in quadrant number 2. All right. Let's get the rest of these down here. -2, -1 is right there. And this guy is in quadrant number 3. And let's look at this last one, 0, 3. 0, 3 means I'm not going to move anywhere in the x direction. Okay, no left or right movement, but I'm going to go up 3. And that gives me a point right here. Now, if I asked you, hey, what quadrant is that in? Look at your picture. Is it in quadrant 1? Is it in quadrant 2? What would you say? Technically, it's not in either one because it is directly on that y-axis. So it is not in a quadrant. The quadrant has to be within there and not lying on the boundary line. So if you get a point that lies directly on the x or y axis and they ask you, where does it lie? It doesn't lie in any quadrant. It's on the axis itself. Okay. So here's your big challenge now for today. And I want to go back here for you. Your assignment is going to be in the workbook on pages 18 and 19. A lot of it's review. Make sure you show your work on page 18 because there's a lot of plugging in of information. And as always, good luck and may the force be with you.